Welcome back to the class on electrical vehicles and hybrid electrical vehicles. In this lecture, we are going to discuss about the working of the fuel cell and its characteristics. The construction of the fuel cell is like a battery only. It is a anode, this is the cathode. Between the anode and cathode, electrolyte is there. This is the container where we are giving the fuel to the fuel cell. The main difference between the fuel cell and the battery is the battery will be store the energy in the chemical form. When we require, the chemical energy will be converted to the electrical energy that is given to the load. But in case of fuel cell, in the name itself, it is a fuel cell. As long as we apply the fuel to the cell, then only it will generating a electrical power. Chemical reaction also will be presented in fuel cell, but it is not going to store any energy in a chemical form. It will be converting the fuel into the electrical power. In this case, the fuel is the hydrogen and oxygen. First, we are supplying the hydrogen to the anode. The hydrogen is nothing but H2. The molecule of hydrogen is consisting of nothing but two nucleus which are sharing the two electrons. So, whenever we are supplying the fuel to the anode, this molecule will be broken into the four parts, two H plus ions, two electrons. Whatever the electrons are producing at anode, that will be passes from the anode to the cathode through the external circuit. If we see internal of the cell, the H plus ions will be moved towards the cathode through the electrolyte. In a fuel cell, catalyst is there to increase the reaction at a anode. This is the chemical reaction at anode. H2 will be divided into two H plus and two electrons. At a cathode, the reaction will be completed if we supply the oxygen to the cathode. Whenever we are supplying the oxygen to the cathode, at cathode area, OT will be divided, nothing but oxygen will be divided into the two ions. Each ion will be grab the electrons which are coming from the anode. It forms a H2O, nothing but a water. This is the overall chemical reaction of the hydrogen fuel cell. So in case of fuel cell, the electrons will be passing from the anode to the cathode through the external circuit. H plus ions will be moving from the anode to the cathode through the electrolyte. The characteristics of a fuel cell. The amount of energy released by the fuel cell is highly depending upon the grip-free energy of a chemical reaction. The grip-free energy will be given equal to change in grip energy, that is equal to NFE, where N is nothing but a number of electrons produced at a anode. F is nothing but a Faraday constant, that is equal to 96,412.2 coulombs per moles. E is nothing but a reversible potential. The maximum reversible potential of the cell is given by the next equation, that is equal to E equal to E naught plus RT by NF, natural logarithm of pH PO of pH2O, where T is nothing but a temperature in kelvins, N is nothing but a number of electrons released at a anode, F is nothing but a Faraday constant, where pH and PO and pH2O are the concentration or partial pressures of reactants in a product. Now we are going to see the characteristics of a fuel cell. On the x-axis we have taken the current and the y-axis voltage. Theoretically, the voltage given by the fuel cell is almost near to the 1, but practically it is not possible. The theoretical value will be denoted in this graph by the dotted line, where the practical value will be denoted by the red line. The practical voltage will be reducing as the current is increasing of the fuel cell. That is due to the internal resistance of a fuel cell. So how this voltage will be reducing as the current density is increasing, that should be known to the designer to use in a hybrid electric vehicles or the electric vehicles. So from this graph you can say that the fuel cell voltage is very low. So we are going to connect these fuel cells in series to get the required voltage as well as the current in parallel to meet the power demand also. The main advantage of the fuel cell is that even though if we are connecting the fuel cells in series, it is not going to sacrifice the overall efficiency of the stack of the fuel cell. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel, so that I am always welcome to answer all your questions.